So the first thing we're going to talk about is feature detection and machining. Now this is a brand new feature that's been added to version 2017. It's available in our mill module and the Visual Cam 2017, Rhino Cam, and also will be available in Visual Cam for SolidWorks as well. Now the feature-based machining, this method, the feature detection, can detect prismatic features and also 3D pocket features. We'll go over an example on how to detect features and how to program toolpaths from features that have been detected. Now the part what I have here is a solid geometry, so you could be working with a solid or a mesh geometry, solid surface mesh geometries. So to detect features from your Visual Cam menu, you select the mill module. Once you have the mill module visible, you have your machining browser, and then you click on Tools Machining Objects, and you'll find the Machining Objects browser, which typically appears over either below the machining browser or over on the side. And you click on the Features tab, which is right by your Tools regions. Click on Features. Now as you select the Features tab in here, you'll see that there is a Create Machining Feature option. Selecting the Create Machining feature will prompt you to select a face. I'm going to pick the top face of this part and then press Enter or right click. And this will automatically detect the features from the part. So I'm going to take this browser and move it over to the side here so all of you can easily see the features that are being detected in here. So you will notice that there is 3 different types of features identified on this part. We have planar faces, and the feature is highlighted on the part. We now have prismatic pockets. You can see that all of these pockets features have been identified on the part as well. And we have a hole feature that's been identified as well. Now once you have these features detected, you could program toolpaths directly from these. So first I would like to program a toolpath for the planar face. So right click on it, it gives you the available operation types. I'm going to pick facing, and the feature is automatically selected. Make a selection for your tool. You can specify your cutting parameters, generate. And there's your facing toolpath for the planar face. We'll now program the prismatic pockets. Select the prismatic pocket feature. Right click on it. You can select facing, pocketing, or profiling. In this case I want to do a pocket machining. I'm going to choose pocket. Specify a tool for it, generate. You'll now notice that the toolpath for the pocket, for all of those pocket features that have been identified, have been generated. And finally on this part I have this hole feature. I would like to program it as well. Select the hole feature, right mouse button click, and I can choose from all of these available operation types, and I'm going to program hole pocketing. Select a tool, and I'm going to hit generate. So there's the toolpaths for each of those 3 features we've identified in here. Now let's go ahead and run a verification. So I'm going to go to the Simulate tab, pick the operation, and then hit play. And there's the verification. So the steps: we identified the features, and then we programmed toolpaths for those features we identified. So in just a few button clicks, you could generate toolpaths for each of these features that you identified. Now I would like to also show you how we can identify other types of features. Now for this I'm going to go into our Rhino Cam product, and you'll see that on this particular part I have some slots and holes on it. So we'll repeat the same process. We'll go into the Features tab under the Machining Objects browser. I'm going to click on Create Machining Features, pick the face, right click or press Enter, and you'll notice that the features have been detected. So I'm going to move this over to the side so you can see all of the features being detected. We have a planar face. We have slots, prismatic slots. You'll notice that there are 2 types of slots, 2 slots in here, and all of the slots have been identified. And as you select each of these slots in the tree, it highlights the corresponding feature on the model as well. that's been identified. And then you have the set of holes, the hole features. Now you could program all of these slots in one operation, or you can split them into two, where I can select all the top 4 slots. I can hold my shift key to multiple select, and I can right mouse button click and choose slotting. Now you'll notice that those slot features have been added. You can make a selection for your tools. I'm going to use a 1/2 inch end mill, establish the slot parameters, and generate it. So in this particular case, you can see that the tool path creates a trichordal tool path when the tool diameter is smaller than the width of the slot. So if you have a tool that's exactly the same width as the slot, the tool path will be different, and which I'm going to show to you in just a moment. So I'm going to select the second set of slot features in here, right click on it, pick slotting, and I'm still going to use the same 1/2 inch cutter, and then pick generate. So you'll notice that the width of the slot here is 1/2 inch, and the tool I'm using is also 1/2 inch, so it automatically identifies the center line to create a single pass for the slotting tool path when the width of the cutter is same as the slot width, or the diameter of the cutter is same as the slot width. Now in the case where the diameter is smaller, this would result in a trichordal tool path. Now we can also identify other types of slots, which I'll give you an overview of what are the other slot types we would be able to identify. Now these are prismatic slots. Typically on prismatic parts you would be able to identify different types of prismatic features. You can also identify pocket features on 3D geometries, and for that I'm going to go ahead and take a look at another part in here. So what I have here is a solid geometry with a cavity, a mold cavity in here, and you can see it has sculpted surfaces on it. I'm now going to go over to the Features tab, click on Create Machining Features. I'll pick the face on the part, and then right mouse button click. So this will identify the features on this part. We have a planar face for the top, and we have a pocket feature. This is a 3D pocket feature that's been identified from this mold cavity. Now once you have the features identified, you can program your tool paths. Right click on it. I can start with the roughing process, specify a tool. I'm going to hit generate. I'm also going to go back and add a finishing pass on it. Pick a parallel finishing tool path, select a tool, generate. So you could detect features from solid surface mesh geometries. You need to make sure that if you're working with surfaces, you stitch them or you join them to a closed geometry, or you can even work with polygon meshes like STL files, identify features, and generate toolpaths. Now you got to remember that in this feature detection, if you have multiple step pockets, there are certain limitations on what type of features we can identify. And here's a summary of the different features we could identify. We could identify holes, closed pockets, open pockets, non-prismatic pockets, like the 3D pockets you looked at in the previous example. We could identify bosses, through slots, through T-slots, prismatic slots, both open and closed slots, and planar faces. So the 2017's mill module feature-based detection and machining allows you to identify these different feature types. Now these are available in starting with right from the standard configuration. So if you have standard, expert, pro, and premium, all of these configurations of our mill module includes the feature-based machining. Okay folks, the next thing we are excited about is to show you some of the new features and new enhancements that we have in 2, 3, and 4-axis machining operations. So I'm going to start with the 2-axis methods in here. And for this, I'm going to go over into RhinoCam, and we'll take a look at how we can identify slots, open slots, and machine them. Now, the open slots can be identified if you have a solid surface geometry. You can use the feature detection in here to identify these open slots, as you can see right there, by using the feature detection to identify them. Or if you'd like to use the conventional way we used to do it, we can select either curves or surface edges to machine open slots. So under 2-axis, you will notice that there's a new machining operation that's been introduced, and this is available starting with the standard configuration of our mill module. So if you have standard, expert, pro, or premium for version 2017, you'll have the slot machining operation. Now this can be used for programming both open and closed slots. In this particular case, I'm going to use slotting and select these open slots. I can use select curve edge regions, and I can either select a surface edge, or I can pick curves as my drive geometry or the part region. And then for the tool, I'm going to pick a 1/4 inch end mill. So I know that the width of the slot is a 1/4 inch, so I'm going to pick a 1/4 inch. Now, had I selected a larger tool, it's going to warn me saying that the tool is too big. It can program the slot. And then we can establish the slot parameters. You can specify the slot cut direction, and you can specify your cut levels in here. You can pick the depth of the 3D model, and you can specify multiple depths per cut if needed, and then pick generate. And there's your slot machining operation. Now, had I chosen a smaller tool in here, so I could go into my machining objects browser, and I'm going to drop an 1/8 inch end mill on it in here. So I can take the 1/8 inch end mill and drop it on top of the machining operation. You'll notice that the operation has been flagged dirty. Right click and regenerate on it. You'll notice that it automatically creates a tricotyl toolpath, since the diameter of the cutter is smaller than the width of the slot. So when the diameter of the cutter is equal to the width of the slot, you would have a single pass. When it is smaller, you will notice that it creates a tricotyl toolpath. So this is one of the new machining methods that has been introduced under 2-axis. It's called 2-axis slot machining, or also known as slotting. You can find it under the 2-axis menu.
One more interjection here. You know, one of the things that you notice, this is the old way of machining in our product, where you're actually going through and selecting curves and edges and surfaces for control geometry. And then also, if you notice, Uday also selected the cut depth to assign for the machining. Now, one of the nice things about the feature-based is all of that is automatically detected in the feature, and we can take advantage of that information that's already in the feature. So Uday, if you can show that feature-based slot machining, that'll be great at this point. Thank you.
Thank you, Joe. So I have the slots identified using feature detection. When I right-click on it and I choose slotting, the slot features have been added in here. And when you make a tool selection and you go into your cut levels, you'll notice that the slot depth has automatically been determined with the feature detection. So when you hit generate, it automatically establishes the depth of the slot. Now, if you'd like to specify depth control, you could always go in here and set your rough depth per cut and generate it, so that'll create multiple levels. So you could either use your conventional way of selecting face edges or curves to program slots or other features, or you can use to take advantage of the feature detection to identify those features and automatically generate toolpaths by not having to go and enter in the depth and other parameters to it. Now there's been several other improvements in two-axis methods, so I'm going to cover them as the next topic. Now the next thing I'm going to go over here is some of the enhancements in two-axis methods, starting with facing, and we'll also talk about two-axis roughing operations. Now for this, I'm going to go ahead and bring in this part. And on this particular model, first thing I'm going to talk about is an enhancement to the two-axis facing operation. I'm sure most of you folks use facing a lot, so we made some nice improvements in facing for 2017. So under the two-axis methods, I'm going to use facing. We'll select the drive geometry, the part region right in here. We'll make a tool selection, and I'm going to go over to the advanced cut parameters. We've introduced high-speed loops in facing, so when you select corner rounding options and generate it, you'll notice that it automatically rounds based on the radius that you put in. So these are high-speed loops that are being introduced in facing, and it's available in both lace cut pattern and also in the offset cut patterns in two-axis facing. So depending on what you choose in the roughing, either you pick the lace linear cut pattern or island offset cut pattern, it'll create those high-speed loops in here for you. And you can specify the radius. I just use the default settings in here to show you the improvements in two-axis facing. The next thing we're going to talk about is two-axis roughing. So when you go over to the two-axis methods, you're going to select roughing. Now the facing and roughing operations are also available in standard, expert, pro, and premium configurations of our mill module. So I'm going to pick the curve or surface edge around the edge of the part as my part boundary in here. And for the tool, I'm going to use an end mill. In the cutting parameters, you will notice that with the facing operation, in the roughing operation, you have the options to automatically choose the cut pattern. When you select use facing cut pattern for core regions, so this cut parameters tab has now been enhanced to allow you to establish the cut pattern for core regions and for cavities in two-axis roughing. So when you have this box selected, use facing cut patterns for core regions, it'll apply the cut pattern that you set for core regions. Either you could use island offset cuts or you could perform a linear cut pattern. And for cavities, you could pick from offset, offset spiral, linear spiral, and we've also introduced high-speed pocketing, high-speed cut pattern in two-axis roughing as well. So this is one of the newer options for cut pattern for cavities in two-axis roughing. So when I generate this toolpath, you'll notice that since I only selected the outermost boundary around the part, so it treats this as an extrusion, and everything that's external to this gets machined away in two-axis roughing. So this method automatically knows the extent of the stock, whether your stock is rectangular or it could be irregular shaped stock. So it knows the extent of the stock to establish the toolpath in two-axis roughing operation. And if you specify the high-speed loops, those would automatically be applied in here as well with the two-axis facing operation. As you notice, as you step through each of these levels, you'll notice that the high-speed loops are being applied for core regions. Now let's take a look at the cavity regions. For this, I'm going to program a pocket operation. So I'm going to use two-axis and pocketing. I'll pick this cavity in here for two-axis pocketing. I'm going to select the interior edge, or I could select a curve. I'm going to use the 1/2 inch end mill. Now in the cut parameters, you will notice that the pocketing operation dialog is unified, where you now also have the option to pick high-speed pocketing as your cut pattern. So rather than having high-speed pocketing as a separate operations in 2016 and earlier versions, now the high-speed cut pattern is part of the pocketing operation. So you could choose from offset, offset spiral, linear, spiral radial, and even high-speed pocketing in your cut patterns. You could specify your step distance in here, specify your cut levels, and then generate. So this creates your high-speed pocketing cut pattern. This toolpath is formed with constant tangential arcs, so it maintains constant cutter engagement and prolongs tool life. So in pocketing, you could now pick from any of these cut patterns, and the high-speed pocketing operation is now unified into the two-axis pocketing operation. So making it easier to program your pocket toolpaths rather than having to go through the process of selecting another method. So the next thing I'm going to be talking about is a three-axis toolpath method, where we'll talk about the enhancements for three-axis. And for this, I'm going to go ahead and take a look at the part you looked at in Visual CAD/CAM, the cavity model. So this is a core, and I'm going to bring in the cavity for it. There it is. Okay, so I'm going to program a three-axis toolpath, the traditional way we used to do it. So go up to three-axis and select horizontal roughing. Now these enhancements for the horizontal roughing are also available in our configuration starting with standard. So if you're using standard, expert, pro, or premium, you will notice all of these improvements and enhancements. Now as you take a look at the cut parameters, similar to what you noticed in two-axis roughing, you will see that in three-axis roughing you have the option to establish your cut patterns for core regions as well as cavity regions. Now for core regions, you could pick between island offset cuts and linear cuts, and for cavity, we've also introduced the high-speed pocketing cut pattern in three-axis roughing. So I know a lot of you folks had asked for this feature. Do we have high-speed pocketing, high-speed cut pattern in horizontal roughing? And here it is in version 2017. So you could choose high-speed pocketing as your cut pattern, specify your step distance. You can set step distance for cavity and core can be independently set, and generate. We'll program your toolpath. I'm going to make sure I pick a 1/2 inch end mill for that, and selecting generate creates your toolpath. There's your horizontal roughing toolpath, and I'm going to show them by level so you can see the high-speed pocketing cut patterns in here. There's your high-speed pocketing cut pattern in three-axis roughing toolpath. So these are the enhancements in two and three-axis machining, and there have been a lot of other minor small enhancements which I'm not going to be touching upon here. You can always refer to the What's New document for those finer details on it. The next thing we're going to talk about is the four-axis enhancements, and we are really excited to introduce true four-axis machining, which is available starting with the expert configurations. The four-axis is part of the expert configuration and above. So we will now take a look at an example for true four-axis machining. So what I have here is a part that has features that are dipping below the rotation center. And parts like these, we were unable to efficiently program these parts in our earlier versions. Now with the 2017 release in the four-axis methods, you will see that there's a new method called drive surface machining. So this method requires you to have a NURBS or a surface-based model to be able to select as your drive surface, and you can have mesh geometries which can be used as surface the toolpath can be projected onto. So in this particular case, since I have a surface-based model, I'm going to use the four-axis drive surface machining in here. And in this operation, I can select the surfaces to be machined. So I'm going to click on Select Surfaces, and I go pick these surfaces in here. So I can just click on it to select the surfaces. Once you make your selections, right mouse button click or press enter to accept it, and you'll notice that the surfaces have been selected, and as you select each of these surfaces, it also displays your surface normals on it. If you need to flip the normals, you have these controls to do it right in here. You make a selection for your tool, you specify your parameters, and in the cutting parameters you can establish your cut patterns. I'm going to use a cross cut pattern. I can also establish my tolerances in here and pick Generate to create the toolpath. So the 4-axis drive surface machining toolpath has been generated, and the tool remains normal to the surface along the rotational axis. So when you go ahead and perform a simulation, you will notice that these surfaces that are below the rotation centers have been able to program it very efficiently with the drive surface machining. So this is a brand new method that's been introduced in our mill module and is available starting with the expert configuration. So if you have expert, pro, or premium configuration, you can take advantage of the drive surface machining in 4-axis. We've also added one other productivity enhancement feature for 4-axis, and that's a new method called Rotary Instancing, and I'm going to demonstrate that in our plugin for Rhino, which is RhinoCam. Now this method is great when you have parts that have the same features being repeated in multiple areas. So you could be programming a rotary instancing and using a combination of 2, 3, and 4-axis operations to repeat or instance the same operation on multiple areas of the same part. So in this particular example, I have 3 operations: a facing, a profiling, and drilling. And as you can see, these features are being repeated multiple times. Now in our earlier versions, we had to go ahead and create a rotate table setup and then program, repeat the operations for each of these. So I would basically end up with 6 sets of these operations in here. Now with the 2017, what we have introduced is a new method called rotary instancing. Now this feature is available in expert, pro, and premium configurations of our mill module. So as you select rotary instancing, you can now specify your incremental table rotation angle. So in this particular case, that would be 60 degrees, and you can set the number of table rotations needed. So I'm going to specify 5, pick Generate, and you'll notice that the rotary instance operation is being created. Now I can drag these operations into the rotary instance operation folder, and now when you select the rotary instance operation, you'll see that the toolpaths have been instanced. So basically you have your rotate table instances being created automatically without having to have the need to go back and program each of those phases by creating multiple rotate table setups. The rotary instancing will take care of that for you automatically. So we'll now go into the Simulate tab and run a verification for this. So I'm going to switch the stock to a cylinder stock from being a box stock in here. And run a simulation. The rotary instances can also be fully simulated, and there it is. And when you post-process these toolpaths, you will see those instances being output in your posted code. So you have your first instance, it outputs the A value for the rotation, and then you have your instance number 2, it automatically rotates the rotary table by 60 degrees and it repeats itself automatically. Now, the next set of new features and enhancements I'm going to be talking about is simulation. We made several improvements and added new features in simulation. And to demonstrate these, I'm going to go ahead and bring it apart so we could take a look at it in our standalone Visual CAD CAM. So I'm going to go back to the part we looked at earlier today, which is the feature-based machining part. We did some toolpaths on it. Now, one of the things I want to point out in the simulation, one of the enhancements is when you look at the simulation preferences, we've now added display for silhouette and sharp edges. So as you enable those under simulation preferences, and when you look at your stock, you'll notice that the silhouette and the sharp edges are now being displayed in your stock geometry. And as you simulate these operations, you will notice them as well in your simulation. So you'll notice those silhouette and the sharp edges appear in your simulation. So this makes the visualization a lot nicer, a lot easier for you to identify those sharp edges in your simulation. As you see it on those pockets right there, it'll display silhouette and sharp edges. So this is one of the many improvements that has gone into our simulation, and this is available starting with our standard configuration. If you have standard, expert, pro, or premium, you could take advantage of this. So I'm going to go ahead and pause the simulation in here and run it through end. Now, one of the other nicer improvements I could talk about in the simulation is being able to assign colors for the cut material simulation. So the colors can be assigned either based on your operation. So when you right-click on a machining operation and then select properties, you now have the ability to assign a color for the simulation. So for each of the machining operations that you program, you could right-click on it and go to properties and specify a color for it. So these colors would be displayed during cut material simulation. Now once you assign these colors, you can enable them in your Simulate tab. Under the status bar, you have this option in here. You can set either to apply the color based on the machining operation that you set in the properties, or you could even assign color for each of the tools that you define. So if you go into your tool definition in here, you'll notice that you have the option to set the cut material color for simulation. Now, as I have set colors for each of these machining operations, I'm going to choose my MOP, which is machining operation. And now when you select the setup and then run your simulation, you will now notice that the cut material simulation colors are being applied for each of the operations that you specified. And this makes your visualization much nicer as you program toolpaths, different types of machining operations. And again, these features are available starting with our standard configuration. So if you have standard, expert, pro, and premium, you can take advantage of all of these nice new features and enhancements. Folks, if you do have any questions, please feel free to go ahead and post those questions in the questions panel, and we'll do our best to get them answered for you. As you can notice here, the colors have been assigned for each of the operation: facing, pocketing, hole pocketing, and profiling. We've also added one very nice enhancement for simulation. Now, as you notice in this profiling operation here, you're able to see these remnants that are being left on the stock material. So in 2017, you now have an option to remove remnants during simulation. So when you select remove remnants during simulation, this will automatically remove those remnants when you run a simulation. So you notice that when I toggle the remove remnants option, it automatically cleared out those remnants. If I go back and perform the simulation again, you will notice that once the simulation is through, those remnants will be automatically removed from your stock material. Now these options, as I mentioned earlier, are available in our mill module starting with the standard configuration. Now I would also like to go ahead and show you one very nice enhancement. We made improvements to machine tool simulation as well. And this is available in Pro and Premium configurations, and we've added newer machine tool models to the list of existing list of machine tools. So as you go ahead and select your machine, you can choose load from file, and you can select your current machine tool. And the list of machines have been enhanced with newer machine tools in here. So I'm going to pick a generic CNC router for this example. And in the Simulate tab, you can toggle the display of machine tool visibility. And as you simulate your machining operations, you can now have the machine tool displayed as well. So this shows your machine tool simulation, and there have been numerous enhancements to the machine tool simulation from previous releases. You could zoom in and zoom out while it's simulating. So there's your pocket operation. The next thing I would like to talk about here is the miscellaneous enhancements to different miscellaneous features and operations that we've introduced. And first, I would like to talk about the enhancements to Feedrate Optimization that's been added to our 2017 release. And this feature is built into the toolpath editor, and it's offered in Pro and Premium configurations. So as you launch the toolpath editor by double-clicking on toolpath in a given mop, you will notice that there's a new option called Feedrate Optimization that's been added. And this allows you to optimize your feed rates, where you can reduce feed rates at corners. So for example, when you take a look at this model, you'll see that there are these sharp inside corners on the part, and you may want to slow it down as you get to those corners. So you can click on the Feedrate Optimization in here, and you can specify your parameters for it. So you can specify the distance before the start to reduce and after to reset it. And also you can specify the percentage of your cut feed rate to reduce it by. You can set all these options in here. And then when you pick OK, you will notice that these have been introduced into your toolpaths. So as we take a look at the toolpath in here, you'll notice that the feed rate has been changed. So half an inch before you make a change in direction in the sharp corner, you'll notice that the feed rate has been reduced by 25% of your actual cut feed rate. And then once you go past, you can notice that it restores the feed rate back. And this is being applied, as you notice, in locations where you have those, we specified the 90-degree corners right there. And as you notice, the feed rates have been reduced and restored. So this is a very nice enhancement, and it's available as part of the toolpath editor, and it's included in the Pro and Premium configurations of our mill module. Now let's go ahead and post-process this machining operation to take a look at the feed rates that are being optimized. So as I post it, the cut feed rate on this operation is set to 40 inches per minute. And you'll notice that half an inch before you get to the corners, the feed rate is dropped to 25% of the cut feed rate, which is 10 inches per minute. And this appears, you can see here, it shows that all of these corners that are the feed rate optimization is being applied. So this is a very nice feature that's available in Pro and Premium configurations of our mill module. Now we also have the ability to output feed rates in inverse time. That would be for 4-axis toolpaths. So for this, I'm going to use an example of the 4-axis drive surface machining that we looked at just a few minutes ago when we talked about the newer enhancements. So when we post-process these feed rates, the toolpath, now in this particular case, I have not established any inverse time feed rate. You'll see that whatever program feed rate that you have is being output or posted in here. Now in the post processor, you have the ability to enable inverse time feed rate. Now this can be done by going into the feed rate section, and you can select output inverse time feed rates, and you can specify your inverse time feed rate code, which is typically G93 to toggle it on and G94 to toggle it off. And now when you go back and post-process your machining operations, this would compute and output your inverse time feed rates, and you'll see a feed rate motion on each of these lines, as you see right there. So there's your inverse time feed rate, and this option is available starting with the expert configuration. The inverse time feed rates applies to multi-axis toolpath, which is 4 and 5-axis toolpaths. So starting with the expert configuration, where you have 4-axis toolpaths, you can take advantage of inverse time feed rates if your machine and controller supports inverse time feed rates. The next nice feature I would like to talk about is useful help for the help system for the tooltips. We've added context-sensitive tooltips, and this can be enabled, and by default it's set to be enabled. If you go under CAM preferences and go to user interface preferences, you will notice that we have context tooltips. Now when this is selected, if you go into any of the machining operation dialog, let's say for example we want to talk about 2-axis roughing. As you select these, as you hover the cursor over each of these commands, buttons in here, you'll see that it gives you a context-sensitive help topic, so you don't have to open the help system, the online help system, to read about it. You can just hover your cursor on top of each of these. As you try to input your parameters, you will notice that it gives you a context-sensitive help, so it makes it much more easier for you to learn and how to use the product and take advantage of the different options that are built into it. So you just hover your mouse over the options, and it'll automatically bring in a context-sensitive tooltips on each of these dialogues. And these are available in all of our configurations. And these have been also added to our other modules as well, not just the mill module. We'll find it in ART and NEST and turn modules as well, the context-sensitive tooltips. This is one of the very nice enhancements to the online help system that's gone in, and a lot of work has been gone into it to get this, to make it easier for our users to use the product. Now there's one other nicer enhancement I would like to talk about is being able to use expressions in results. So you can see that when I hover the mouse on it, the context sensitive tooltips pops right up there. So it tells me what the expressions are. So I'm going to enable the expressions, and let's take a look at how we can use these expressions in here. Now I have a bunch of tools that I've created in here. I would like to go ahead and add a new tool, and I want to create a new tool. Let's say I want to put in a 3/8 inch end mill. So rather than figuring out what that is in decimals, I could enter in 3/8 and it'll automatically, the expression would compute the decimal value for what you put in. So you can use these in all of the input boxes in VisualCAM's mill module, RhinoCAM's mill module. You can enter these values in here, and you can define a new tool. And you can also establish these parameters in your operation dialogues in here. So if you go into any of the machining operations, let's say you want to program a pocket operation, you could go into your cut levels, and you can specify a total cut depth. You want to go an 1/8 inch deep, you just specify it. You can either hit the tab key or just click on the expressions tooltip, and it automatically establishes the value that you put in there. So you don't have to go ahead and figure out what, convert it to 0.125 and enter it. You can use 1/8 and it'll automatically factor it in for you. So those are the very nice enhancements, some of the miscellaneous enhancements that have gone into the product. Now the next thing I'm going to talk about is fitting arcs to toolpaths, and also we'll talk about surface selection for machining. So I have a core model in here, and I've generated a parallel finishing toolpath to it. Now we have a global options added to our 2017 release, and if you go over to machining preferences, you can now specify a maximum arc radius to fit arcs to toolpaths. So depending on what your machine controller can handle for arcs, you can specify a maximum arc radius, and you can constrain it to the 3 principal planes, which could be X, Y, XZ, or YZ. And for example, I'm going to set the maximum arc radius to 5. In this case, it's going to be 5 inches since I'm working in inch units. And as I regenerate this toolpath, you will notice that the maximum arc radius is restricted to 5. And any arcs that are over 5 inches in radius would be linearized. Anything under 5 would be output as true arcs. So you have the option to set it globally and program your toolpath. So if you have a limitation on what your controller can handle for the maximum arc radius, you can specify it right in there. Now, there's one other nice feature that's been added to our 2017 release is the ability to select surfaces for machining. So you need to have a surface-based geometry, so the surfaces have to be not stitched together, meaning they need to be exploded, so you would be able to select those surfaces individually. So when you go into a machining operation, let's say in this case it's a 3-axis, you will notice that there's a new tab in here called Part Surfaces. Selecting Part Surfaces will allow you to pick a surface or a bunch of surfaces for machining. So I can click on Select Surfaces, and I can make my selections in here. Right mouse button click, and then select Generate. Now there's a couple of things I would like to point out here is the surfaces that you select are going to be, the toolpaths are going to be generated for those. And one thing that needs to be noticed is it will not check against any adjacent surfaces. So you would want to make sure that when you make your selections, you select the surfaces and that you want to machine. So there is no gout check built into adjacent surfaces at this point of time, but you can directly select surfaces for machining in here. Under the miscellaneous enhancements, there's one other enhancement I would like to talk about is in drilling operations. So as you go into machining preferences, we've now added an option to linearize the drilling outputs. For this would be applicable for standard drill, deep drill, brake chip, countersunk drills. So rather than outputting them as CAN cycles, which could be a G81 for a standard drill or a G83 for a PEC or a deep drill cycle, we could now output them as linear motions or simulated cycles, we call it, which could be just output them as bunch of linear motions. So some of the controllers which do not support these CAN cycles can now be output as linear motions. You just have to select this checkbox in here, and then as you generate your toolpaths and post-process a drilling operation, they would be output as a linear motion. So this gives you an overview of the newer enhancements that we've added to our milling module. Talk about some of the enhancements in our other modules. And if you take a look at the What's New document, you will find it in the What's New document. All the enhancements have been listed, and there's been enhancements to our nesting module as well as the art modules of our product. And you can refer to those. The nesting enhancements can be noticed in the What's New document in here. As you see it, the nesting enhancements include the ability to automatically update the sheet count based on the estimated number of sheets, and you can automatically also update the count for parts. So if you have hundreds of parts and you want to set the count as 2 for each of them, you can automatically update those rather than having to manually go and update each of those parts. And we've made some performance improvements, memory improvements to the art module, and I'm going to show you an example for that in the art module. Now, in the previous releases in the art module, we used to have some spikes around the mesh geometries that you can see from this screen capture. I'm showing it to you right in here. Now with our 2017 release, we made improvements to those as well. So as you generate your projects, and you'll notice that those spikes have been completely eliminated in most of the areas, and you can see the result is much nicer and smoother. And also we made improvements to working with large resolution meshes, so you can create a much higher resolution, and better memory management has been also made into the art module. So folks, those of you who run the art module can take advantage of those in our 2017 release. And you can run through and look through the entire list of enhancements in art, mill, and nest modules by taking a look at the What's New document.